In this lecture, we will discuss about SR NAND gated latch. That also positive level with a positive level. Okay. So this is the symbol. So it contains three inputs. Two are data inputs SR. One is control input. We can call it as enable or clock. It will work with the clock levels. Okay. So here we take in positive level means its value will be 1. Clock or enable value will be 1. It means it is working with positive level trigger. Okay. Their outputs are 2, Q and Q bar. Okay. So we have to write straight to S Q. In the diagram also straight to S Q. So why it is called gated latch, we'll see. Okay. So whatever the input side 2 NAND gates are there, these are called gated part or driving part. And these last output side 2 NAND gates are called latch part. This 2 NAND gates nothing but non-gated latch part. Okay. Suppose if you take a bus, driver will be at the starting. So that's why this is called driving part or gated part. Okay. This is the latch part. So latch part at output side, driving or gated part at input side. So in the non-gated latches, these gates are not there. That's why that is called non-gated latch. Okay. Right. See the construction here. Yes, we connected to this, or we connected to this gate, and the clock is common to both gates. Okay, this is the construction. Now we'll see the working. So before going to further process, we should have this latch truth table. This latch is a non-gated SR latch. So that truth table we should have. So I taken the truth table in a simplified way. So we know from the non-gated SR NAND latch, when inputs are 0, 0, we get invalid. When inputs are 0, 1, it means S0 or 1, we get set 1. And when S1 or 0, we get reset 0. And when both inputs are 1, 1, it will be hold. Okay. So in any gated latch or flip-flop also, the design process is after drawing this symbol and logic diagram and this latch truth table, non-gated latch truth table, then we have to do characteristic table. Then we have to do excitation table. Then we have to do characteristic equation. These are the steps. Okay. So this is step 1. This is step 1. This is for step 2, not step 2. This is for step 2. Then this is step 2. Then step 3. Step 4. So these all 4 steps are common to gated latches and flip-flops also, for both any gated latch and any flip-flop. Okay. Now we'll see how to do characteristic table. So in the characteristic table, generally we take the inputs and present state and then we predict next state. Okay. So here the format is we take enable or clock. So I mentioned this is positive level. So positive level means it will work whenever we apply 1. Okay. And we will see what happens when we apply 0 also. For positive level, if we apply 0, what will happen? 0 means negative level. For positive level circuit, if we apply negative level, what will happen? And for positive level circuit, if we apply positive level only, then what will happen? Both will see. Okay, right. Suppose when I apply 0, it means for a positive level circuit, if I apply negative level, whatever the data inputs, SR can be any value. It can be 0, 0, 0, 1, 1, 0, 1, 1, and QN value also can be any one. Whatever it may be, it will become hold. Okay, Qn n plus 1 become Qn only. Okay, so here in this condition, circuit is not triggering because not triggering means positive level circuit will respond to only positive level, not to negative level. It is not responding or not recurring. However, it is in previous, it will be like that only. There is no change in the circuit. That's the meaning. Okay. Now we'll see what will happen if we apply positive level. Okay. So how to write this S value, R value, Qn value, we'll see. Suppose there are two inputs, means four combinations, 0, 0, 0, 1, 1, 0, 1, 1 will come. So this Qn can be 0 when inputs are 0, 0. Or it can be 1 also when inputs 0, 0. And Qn can be 0 when inputs are 0, 1. Or it can be 1 also when inputs are 0, 1. Like that, Qn can be 0 when inputs are 1, 0. Or it can be 1 also for 1, 0. And finally, Qn can be 0 for inputs 1, 1. And it can be 1 also for inputs 1, 1. Okay, like that we have to write. In any gated latch or any flip-flop, we have to write like this only. Okay, right, remember. Now we'll see Qn n plus 1 values and state values, state names. Okay. So here now I am applying S equal to 0, R equal to 0 and clock value 1. Then what will happen? Go to the circuit diagram. Here it is 0, here it is 0, here it is 1, here it is 1. It means if any one input is 0, output become 1. Any one input is 0, output become 1. It means 1, 1 are going to non-gated latch. When 1, 1 going to non-gated latch, see what will happen? Hold will happen. This hold will happen. So circuit will become hold. It means n plus 1 become n only. What is the n value? When we apply S0 or 0, n value is 0, so n plus 1 0. And n value 1 also. So that's why n plus 1 value also becoming 1. So this is called hold. 0 is there, 0 is coming, so hold. 1 is there, 1 is coming, so hold. But what's the difference between this hold and these two holds? This hold is happening because of no change in the circuit. No change means circuit is not responding. Okay. However, it is in previous like that only. But here it is responding, but it is giving same as previous output. But here it is responding. That is the triggering. That is the meaning of triggering. Okay, that you have to observe. Now we'll see next condition. What happening when we apply S0 or 1? S0 or 1. We'll go to diagram and we will check. So here I am applying 0 and here 1. Clock is 1, 1. Okay. So if any one input is 0, so it will become 1 here. Here below both are 1, so it will become 0. So it means 1, 0 is going. When 1, 0 going, what is the output? See here. 1, 0 going, what is the output? Reset. Reset value is 0. So reset. Okay. Here reset coming. So reset means value 0, 0. In both cases 0, 0. Okay. Once observe, this 0, 1 is going to gated part, not to latch part. But latch part is getting 1, 0. Okay. That's why reset. That you have to observe. Okay. Next condition. In this case, similarly, you can apply driving part getting 1, 0. But latch part will get to 0, 1. When we get 0, 1, we know it will become set. Then 1, 1 is happening. Latch driving part getting 1, 1, but latch part 2 getting 0, 0 at input. So it will become invalid. So invalid X means here what you have to observe. Here X means 0 or 1. Here X means 0 or 1. Here X means 0 or 1. And here what it means, here invalid means this Qn plus 1 value and Qn plus 1 bar value both are same. That's the meaning. Okay. Now we'll see excitation table. This is step 10. So in the excitation table, we write n plus 1. This n is the present state, n plus 1 is the next state at input side, and we will predict what can be the SR values, input values. When we get n plus 1 these values, what can be the SR values, input value. Like that we do excitation table. Okay. So if there are two inputs means 0 0 0 1 1 0 1 1 will come. 4 combinations. So now how to write this SR values in excitation table we'll see. So what is the n plus first value combination 0 0. Now go to characteristic table. From the characteristic table only we have to write excitation. See n plus 1 value here one time 0 0 and here one time 0. Okay. So here in this two, here 0, here this 0 and this 0. What is the S value? 0 only. So S we are getting same value, so it will be 0. But R we are getting different value. See here 0 it is 1. Whenever different value you have to write like X. Okay, so we will get 0x. For 0 0 we will get 0x. Now we will see for 0 1. But 0 1 is there at one place only. See here this 0 1 there at one place. But 0 0 there at two places. That's why we compared. So for 0 1 only what n plus we can simply write S1 or 0. S1 or 0. Okay. Next we'll see 1 0. S equal to Qn equal to 1 and n plus 1 equal to 0. For 1 0 we are getting 0 1 S0 R1 S0 R1. Now we'll see for n plus 1 1 1 it will be at two places. So here at one place and here at one place. So here what we getting S value 0 and here we are getting 1. So yes we are getting different but R we are getting same. Okay. Same is what we getting are 0 but S different, so we write X. So like that we have to write excitation table. Okay. Now characteristic table. Characteristic table. So what is meant by characteristic table? We have to determine next state Q1 plus 1 value by assuming data inputs and present state as K-map variables. Okay. So from the characteristic table only we have to do characteristic equation. Here we have to determine this n plus 1 next state by assuming this Qn and SR as K-map variables. Okay, this Qn is also called present state or state. Okay, so whatever the 1 values or x values, okay, if we are doing with SOP map, 1 values or x values, we have to substitute those in the K-map and we have to determine the equation. So I substituted and I determined. So I got Qn plus 1 equal to S plus Qn R bar. Okay. So what's the benefit of this one? I can determine Qn plus 1 value by substituting S value and Qn value R value in this equation, right? Okay, that's the benefit. So here, whatever this whole happening, this value is going to this side. Okay, like this from left to right side they are going. But when we take hold in the non-gated latch, how it happened we'll see. This is in gated latch, but how it happened in non-gated latch that we'll see. See here hold is happening from top to bottom like this. Okay, but we no need to remember right to left to top to bottom like that. Just I am showing. Observe the difference.